Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode problem number 905, sort array by parity. Given an integer array nums, move all even integers at the beginning and of the array, followed by all odd integers. Return any array that satisfies this condition. They are asking us to move all the even integers to the beginning and all the odd integers to the end and return that array. They didn't specify any relative orders, right? Now, let us see this example 3124. 3124, right? 3124. Now, they're asking us to return all even numbers as first, all even numbers at first, and all odd numbers at second. We can return this array. Also, we can return this array. Also, we can return this array. We can also return this array. The main goal is to the even numbers should be come at front and odd numbers should come at the end of the array. Now, how to approach this problem? In this example itself, we just taken the even numbers first and put in the array. Then we took the odd numbers second, then put in the array. So let me declare two arrays, separate arrays. It may be even and another one is odd. Fine. Now I am traversing through that. I am traversing to the given array. Okay. Fine. What is the first element? It is 3. 3. 3 is even or odd? It is odd. So put in the odd array. Now going to the second position. One is odd or even. One is odd. So put in the odd array. Now 2 is odd or even. 2 is even. So put in the even. 4 is odd or even. Even. So put the 4 in even array. Now we shall we shall combine this both. We shall combine this both. 2 comma 4 comma 3 comma 1. Have you got the solution? Have you got a solution? Right? So this is what the simplest brute force method. This is what the simplest brute force method. Brute force method. Okay. Talking about the time complexity and space complexity. Time complexity will be O of n and space complexity will be O of n because this even and R array. Right? Now, going to the second approach. Second approach. In second approach, take the same example 3124. Now I can take a resultant array. Now I can take resultant array. First of all, check whether 3 is odd. No, 3 is not odd. Sorry. Check for even numbers. Whether 3 is even? No. Whether, wait a second. Yes. Whether 3 is even? No. Whether 1 is even? No. Whether 2 is even? Yes. Then write this 2. Whether 4 is even? Yes. Then write this 4. Completed. Now, again, second time, traverse to this whole array. Whether this 3 is odd? Yes. Whether this 1 is odd? Yes. Whether this 2 is odd? No. Whether this 4 is odd? No. First, in first traversal of array, we get the even numbers. In second traversal, we get the odd numbers. Fine. So this is what the second approach. Second approach. Talking about the time and space complexity. Time is also O of n, space is also O of n. Fine. Now, how can I optimize it? How can I optimize it? If I can carefully observe this, I can carefully observe this example. This 4 should come in this place and this 3 come in this 4 place, right? This 2 should be swapped to be in the correct place, to be in the correct place. Yes. Now in this 1, this 2 will be there and this 2, 1 will be there in the output. Yes. Yes. So the correct output will be like this. What I done here? Swap. What I done here? swap, right? So by using this, by seeing this approach, I can say it is two pointer. It is two pointer, right? And it is the two pointer which approaches each other, that is towards pointers, towards pointers, right? This is a type, right? Now, how to approach this solution? How to approach this solution? Just see here. Let me take the example 3, 1, 4, 2. Now, I take a even pointer here. I take odd pointer here. First, we want the even numbers. Then we want to have the odd numbers, right? Just I change the color. Fine. Now whether this 3 is even, whether this 3 is even. No. So even pointer is at a wrong position. Even pointer is at a wrong position. Fine. Now whether this 2 is odd. No. So odd pointer is also at the wrong position. Now can I initiate the swapping? Now can I initiate the swapping? Just swap. So my array will be 2, 1, 4, 3. Right? Now I can shrink my pointers. O will be there and E will be there. Now whether my even pointer is at the even number. No. So even pointer is at the wrong position. Whether my odd pointer is at the odd number. No, it is at the wrong position. Then swap it. Right? Again, let me explain with any other examples. See here. Just take 2, 4, 2, 5, 4, 1, 3, 6 maybe. Right? No. Here is my even pointer. Here's my odd pointers, right? Whether my even pointer is at a even place, that is in the at a even number. Yes. So it is at the correct position. It is at correct position. Then why I want to bother about it, right? So I just move ahead. Now whether this 5 is even. No. Then now even is at wrong position. Whether the 6 is odd. No. Then odd pointer is at wrong position. When these both pointers are at wrong position, I can swap. Now while swapping, second, while swapping, we get 6 here, we get 5 here, right? Now I can shrink my pointers O and E. Fine. Now whether this 4 is even. Yes, this 4 is even. I can move this pointer here. Whether this 1 is even. No. Then even at the wrong position. Whether the 3 is odd. Yes. Then just move towards it. At this point, when two pointers are meeting, I can stop the loop. Right? So this is what the approach. So this is what the third approach. And also we can do this in the another approach too. Which is fourth approach, in which we use forward pointers. Both pointers moves at the same direction. Okay, maybe one pointer is I and J, they move towards the same direction. Fine. Let me take the example 3, 1, 4, 2. Now I just assign two pointer to this zeroth position. Fine. Now let me iterate this E to one by one. When I found this first even, when I found a even number, just a even number, then I can swap this even number with this odd portion, because we want even numbers at the first and odd numbers at the last. So I can swap this even towards this odd and this odd towards this even, so that my array will be like 4, 1, 3, 2. And where are my pointers? Even pointer is at this position, and odd pointers will move one position, or even pointer also move one position. Right? Now, whether my even pointer is at a even number, yes, then I will swap again with this odd pointer. Now I'm swapping this. What is my result? 4, 2, 3, 1. Now my odd pointer is here, my even pointer is here, and even pointers exceed the array limit, so the loop stops. So this is my fourth approach. Right? In this approach, we are just taking this even pointer towards the even number. While we are countering this even number, we just swap with odd pointer value, and make the odd pointer +1, because in that position a even number will be occupied. So odd pointer just move to the next position, that is the odd position. Okay, where the odd numbers lies. Fine. So fourth and fifth, when this fourth and third approaches fails, when this third and fourth approaches will be failed, when I ask for relative order, that is, if I give an array of, take for example 3, 2, 1, 4, then I should get the array of 2, 4, 3, 1. See here, first here comes 2, then only 4, first here comes 3, then only 1, right? But here this fourth approach and third approach will be failed. Why? Because just see this example. Here is my even pointer, here is my odd pointer, right? Whether this even pointer is at wrong position, yes, even pointer is at wrong position. Whether my odd pointer is at wrong position, yes, it is at wrong position, because there is a even number, right? Now what I do, I just swap. What is my value? 4, 2, 1, 3. Now my even is at 2 and odd is at 1. Now whether this even pointer lies at the even element, yes, and odd pointer lies at the odd element, yes. Don't do anything, just move here and move, this is just move even pointer to the one step ahead. Now the loop terminates and the loop ends. Now what is the answer? The answer is 4, 2, 1, 3. But actual answer is 2, 4, 3, 1. But the actual answer is 2, 4, 3, 1. See here, this is the answer I got. This is my actual answer. So here's why third and fourth approach will be failed. You must try first and second approach. For this relative order, you must try one and second approach. Now let me explain the code. See here, it is my first approach. My first approach is just declaring an empty list called result. Then I am iterating to every elements. If I encounter a even numbers, I will append in first loop. Then in second loop, if I encounter any odd elements, I will append with result. Then return the result. Fine. This is my first approach. Then my second approach is I declare odd and even list, an individual list. Then inside the loop, if the element is even, I will append that element to the even list, and if the element is odd, I will append that element into the odd list. Then I will return even plus odd. That is, I am just combining the both. First even list, then odd list. Fine. This is my second approach. Now, my third approach is forward pointer approach. 2 pointers, that is forward pointer approach. See here, I declared odd as 0, then I am iterating by using the even variable. If nums of even mod 2, if the number is even, what I do, I will swap. I will swap with odd pointer, then I will make the odd pointer to the next position, right? Return nums. Fine. This is the forward pointer technique. Now, 2 pointer approaching technique. See here. In this, I have declared two variables, even and odd, and even as 0 and odd as the last element. Now I want to make sure nums of even mod 2 is equal to 0. That is, whether the even pointer is at a even element. I want to make sure whether the even pointer is at the even element. If it is so, I want to plus 1. Why? Because we want even pointer at the odd element and odd pointer at the even element, and while swapping, it gives the correct answer, right? As we saw earlier, the even pointer should be lies in the wrong position and the odd pointer should be lies in the wrong position. While swapping this both, we will get the correct answer. So that's why when the even position is at a even number, I will plus 1 the pointer. Now, when the odd pointer is at a odd element, I will minus that odd pointer. Else, I will swap them both. Then odd minus equal to 1, even plus equal to 1. I will move even pointer 1 and odd pointer 1. Fine. Now return nums. Fine. This is the fourth approach. Fine. Just practice in your own way. And this is the approach for this problem. Thank you.